Hello everyone, this is Dashi Liang from Northeast Forestry University. It is my great honor to make this presentation entitled High Efficient, Stable, and Renewable HMO Cellulosic Film for Lithium-ion Extraction from Seawater. As you can see from the data, the demand for lithium within the past 10 years is increasing rapidly, especially in the field of lithium-ion batteries. However, the world's lithium resources are limited. So how can we make ends meet? Let's take a look at the ocean. We have over 230 billion tons of lithium in seawater. Unfortunately, the concentration of lithium ion is pretty low, especially when you compare it with other metal ions. So can we make it real? Is it possible that we effectively extract lithium from seawater? The answer is yes. We have made efforts to prepare a renewable and recyclable hydrogen manganese oxide modified cellulose film as a sort of lithium sieve to extract lithium from seawater. As you can see from the results, HMO was embedded in cellulose frameworks with high monodispersity. According to its facile preposition approach, the composite film can be easily scaled up for roll-to-roll application. Selective uptake of lithium ion from aqueous solution containing various solutes is important for practical applications. To examine the selectivity of absorbance, the HMO particle or HMO cellulose film was introduced into a solution containing sodium ion, magnesium ions, potassium ions, and calcium ions. Both the HMO particle and HMO cellulose film showed high selectivity for lithium ions. At the equilibrium state, the HMO particle absorbed 2.17 millimole per gram lithium ions, which is considerably higher than the obtained for the other solutes, which are 0.028 to 0.093 millimole per gram. The high selectivity of HMO for lithium ions is due to the favorable exchange between hydrogen ion and lithium ions. In contrast, the other ions are larger in size than the cavity adsorption site and have a higher free energy to hydration than lithium ions, thus hindering access to the HMO cavity sites. The reusability of a film is essential for its practical application. The 50% HMO cellulose film was subjected to repeated, which is 8 cycles adsorption-desorption processes, and the lithium ion adsorption cavity and the tensile strengths of the films were determined after each cycle. In general, lithium uptake remained relatively high and stable, with only a slight decrease observed from 18 to 15 milligram per gram after the 8th cycle. The decrease may be attributed to partial loss of HMO from the film during the test. Seawater contains various ions. Among them, lithium ion only has a very low concentration of 0.12 milligram per liter. As observed from this figure, the 50% HMO cellulose film displayed a lithium ion extraction efficiency of 99.4% from seawater, which was considerably higher than that of other ions. These results were consistent with the distribution coefficient KD, and the KD of lithium ion was 2.5 by 10 to the power 5, which was higher than other ions. Thus, the results show the great potential of HMO cellulose film for application and the selectively separation of lithium ion from aqueous solution. Here I want to thank my students for their excellent work, and thank you for your attention.